Hello, everyone. I'm Mike Simmons, the founder of Astronomy for Equity. Welcome to the podcast. Today, we have two amateur astronomers who are very big in public outreach, but in ways that are different than what we usually see. We have Cesare Pagano from Italy, who is the chair of the Inclusive Outreach Sub-Working Group of the International Astronomical Union's Executive Committee Working Group on Equity and Inclusion, which I can never remember the whole thing. And basically that means making sure that we include everybody in astronomy outreach, which is very, very important. We also have Andra Stoica, who's the co-chair of that sub-working group. I'm a member as well, very active, and we're going to talk about some things that you may not have seen before. So welcome, Cesare and Andra. Cesare joining us from Italy, Andra from Romania, and it's great to have you here. Thank you.
Hello, everyone, and thank you, Mike, for arranging this. It's a pleasure to be here.
Well, this is going to be really, really interesting, I think, and it's one of my favorite topics because I've been involved in this for a long time as well. And so the inclusive outreach sub-working group of all that other stuff that I'm not going to try and repeat, the International Astronomical Union, of course, this is very, very important, but astronomy includes everybody, right? I mean, we do outreach, we go out, everybody's welcome. Who are we missing?
Yeah, no, actually, inclusion can have many dimensions. It can be like a cultural inclusion. People may have different cultural background and, speak about astronomy in different ways, have different references. It can be a gender inclusion. But yeah, in our working group, we decided to focus on inclusion of people with disabilities. So people who have visual impairments or hearing impairments or people with motor impairments. The idea is to expand the way we do outreach, adopt new practices, new languages, so that they can enjoy the outreach activities and approach astronomy just like people without this impairment. And it's just a matter of using the right language in a broad sense, where language can be a tool. But it can be done, it has been done, and that's why we are here.
And Andra, you've been doing this as well, and you've been reaching some people, and the thing is that most people don't realize these people are excluded because they don't see them. They're not at the events. But you have been working in astronomy for the blind, and every time I talk about astronomy for the blind, people's eyes widen. It's like, what does that mean? We think of it as such a visual thing. And so how is it possible that blind people can enjoy and take part in astronomy?
Actually, I recently got this reaction at a recent conference in which I participated, and people were, wow, do you really do astronomy with the blind people? Yes, we can do that. We have special tools. We have not necessarily special methods, but simplified methods for people with disabilities, especially for the blind and visually impaired. Of course, it's easier when a person is only visually impaired, but it's possible with the blind also. It's very fun. We have different toys, I can name them, that they enjoy, and they can imagine astronomy. Actually, astronomy is not visual, except for the sky that you can see with your own eyes. Astronomy is mathematical, and everything can be transposed into tactile, audio, and other using other senses. We think it's visual, but in reality, it's not really.
And most of astronomy, the Chandra X-ray telescope, the Hubble Space Telescope, when it's doing infrared, and JWEST that is doing infrared from space, they're in space partly because we can't see those things down here, those wavelengths. There are other reasons too, but most of and radio telescopes, we can't see that stuff. So we make pictures out of it. But we're going to share some slides here of some of the things that you have done that show what we're doing. So just talk us through this.
These are some tactile sheets. They're actually simple drawings made 2.5D, printed in 2.5D, not 3D fully. This is a rubber sheet, and when the printer head goes over it, it emits some heat, and the rubber goes out a little so that it can be touched and felt. And the visually impaired and the blind people can actually see the picture by touching it.
Mm-hmm. What's the reaction? I mean, these are things that I know they've heard about. This looks like a child, probably very interested, just like any other child. The curiosity is the same, everything else. What's the reaction when they get a chance to understand this a little better this way?
Actually, they are used with the tactile sheets because all the schools use them a lot. But the greatest reaction is when you show them something 3D, or if you can jump to the planetarium.
Oh, the planetarium. Yeah, let's look at that. Okay. Well, let's real quickly here. There is something 3D there. It's a little bit different, though.
Yeah, here we actually use very simple tools. This is a balloon with some star stickers on it that you can fill with your hand. And here I think I was explaining the expansion of the universe. And the kid was touching the balloon and seeing the stars moving apart one from another in all directions and with same speed. And here you can have a presentation only on this topic, and you can talk about it, I don't know, 1 hour, 1.5 hours, and they wouldn't get bored of this this activity.
That's the same analogy we use for sighted people. We just they don't have to feel the balloon, but it's otherwise exactly the same, just to this one little adaptation that they have to touch it and be able to feel those stars there rather than see them. So here, I think is this what you're looking for?
Yeah, this is a good example also, because this is a tool. This orrery is one of the tools that amazes the blind people, including the adults, not only the kids, because they seeing everything in 2D. They never imagined the rotation of the planets around the sun. And they are amazed, oh, wow, so the planets really move like this. So this is the sun. And when you explain that the sun also moves, they are starting to be amazed. So this is the first step into their amazement. Here also you can see a tool with the distances, the real distances of the stars within a constellation. There are some notions they heard about, and the more complex information amazes them.
Yeah, and the idea that this very simple concept that things are moving around, they don't see this. We describe this visually, and I think some people are surprised to know that they really can't get a concept of this in 3D because they haven't experienced. I'm gonna go to something that I think is really an amazing example of that seems so simple to us.
Yeah, this is what I was talking about. This is the most impactful tool that we have. This is made by the Biomare Planetarium, and we are using it. And the greatest impact that it has is that the blind people can understand that the sky is curved. They usually don't understand this. Seeing everything on 2D, maybe they learn at school about the sky, the constellations, the planets, but they only see it in 2D sheets. And when they start exploring the dome, they start wondering, wow, the sky is actually curved. This is how you perceive it. And I understood from the makers of this planetarium that their idea also came from a blind person they had visitors there exploring some 2D, 2.5D materials, and they started talking about a planetarium, and the blind person asked, what is a planetarium? They explained about the projection on a dome, and they say, wow, but we want to see that also. So do something for us. That's how they got to this resource, this wonderful resource that is very helpful.
So in this case, they can reach up and feel the sky and realize that it's curved and where the stars are, which seems like something that would be so obvious to us, really. Cesare, I want to ask you about this, because the sub-working group, the whole idea is to share these materials and get more people to include these people. But there's another aspect too, that as a member of this sub-working group, I've been involved with this for a while too. And we had a session in Astronomy for Equity, which we'll get to later, where we had somebody from a major NASA facility who's doing 3D printing of objects in space, who said, oh, I never realized that, because she just hasn't experienced that. So this working group is not just to share how to include other people, but to educate people about the need for this and how the usual things that we do just don't work. If you have a blind person there and you say, well, if you're looking at the night sky, they'll never figure out what you're talking about if they don't know, because, again, we're used to this. We go out from when we're very, very small and we see the sky as being curved, but they've never seen that.
Exactly. And actually, this is the key point, right? Doing inclusive outreach is not a miracle. It just requires some skills. And since there have been experiences around the world since probably 2009, the International Year of Astronomy, someone started with this. And then in many places, we have examples of people who have developed this kind of skills and experience. So the idea of the working group was to share these experiences, document it, publish it, and build a community around it, so that the many outreach practitioners around the world can learn from others and adopt inclusive practices without reinventing the wheel every time. So there is a wealth of knowledge around that can be much more worth if it's shared and reused. Yeah. And you were mentioning about the different background and attitude of people with impairment. That's very true, and that's the key. That's why among the tools we developed, there are some good practices. How to work with the blind person, how to work with the person with the visual impairment. And just to be more concrete, I can mention a couple of things I learned. It has been a great learning experience for me. Now, when you deal with the blind people, first of all, there is a huge difference if they are blind from birth or if they've developed blindness. Because people who are blind from birth, they don't have the concept of colors. They don't have the concept of clouds. So you cannot make analogies with these terms. Actually, you can explain colors with analogy with the sound, the different frequencies, and so on. But you have to keep in mind what's their paradigm, what's their basic set of concepts, and build on those. I still remember one of the more touchy feedback I saw from a person who was blind from birth, who attended one of the astronomy class. Simple things like the movement of Earth, the seasons, things like that. Our surrounding. At the end, she was very happy because she finally understood what is a sunrise and what is a sunset. Now, if you think a person becomes 30 and has never experienced a sunrise or a sunset, that's let's say the reward for what we are doing at the end.
That's amazing, and of course, there's a beautiful background there of the moon setting behind some hills. Seems to be taking a very long time for that to go down, Cesare.
Yeah, it can take forever.
And it's such a simple thing to us, and it's such a beautiful thing. And even, if you do an audible caption for this and say, with the moon setting behind the hills, what you're saying, and this is not something I'd thought about before or heard about, that might not be adequate because they don't know really what that means.
Exactly. So you have to work with their paradigms and set of acquired knowledge, and just refer to that. So if someone is blind from birth, they never realized how, what is a sunrise? Why the sun disappear? What does it mean? What does disappearing mean? So
yes, this is disappearing. Just like if it doesn't appear to them, it can't disappear. So analogies with sound or something like that. And I'm going to bring up here a page from the website for this working group about different kinds of impairments. Now, these are the resources, and there are lots and lots of resources out there that people don't realize for different kinds of impairments, whether it's visually impaired. There's also for the deaf, mobility. There are other kinds of exclusions, such as gender, LGBTQ, and things like this as well, where the people are not visible to us because they're just not there. So we might mention those as well. There are, for example, I know that sign language that the deaf use, there historically has not been any signs for the things that we talk about. If we're talking about cosmology and so on, they can't hear us. They don't know what we're saying, and the person who's signing can't translate it because they don't have words for it. So that's changing now too, I believe.
Yeah, exactly. And actually, just like an evolving language, also the sign language is going through some evolving troubles, let's say, because there are different people developing signs for this. Like I have the experience in Italy. There is the professional community like IAU and so on has been working on some official sign languages for astronomy. But then there are also deaf amateur astronomers who have developed their own signs in the meanwhile. So we have different signs, some used in the everyday life by amateur astronomers who are deaf, some others coming from a more academic environment and so on, and they don't always match. And there are some discussions about which ones to use. I mean, just like an evolving language. So the important thing is that it's happening, because that means that eventually we will have science to speak about astronomy. But anyhow, we are also considering the international dimension of this, right? Now there is a Romanian, an American, and an Italian speaking in English, and it's pretty common. For the sign language, it's more difficult. Sign language is very much country dependent. There is an international sign language, but it's more difficult. There is a double translation involved and so on. So, getting where there is an internationally recognized set of signs for astronomy will take a while. But as I said, the important thing is that the discussion is happening and things are moving.
And one more example here too that people don't usually think about. Some of us have encountered this, where people who are restricted to wheelchairs are not able to reach the eyepiece of a telescope. I mean, we have this too with children. Every time the eyepiece is up high, and if there's not a stool, and the parent picks them up and they grab the eyepiece to stabilize themselves and move the telescope. So bringing the eyepiece to the person in this case is essential, and this is one of the solutions for doing that.
Right, and there are also others. This is just one example. Especially amateur astronomers are very creative when it comes to finding solution in a cheap way. So there are many ways to take an eyepiece to the eye of a person on a wheelchair. The question is, why doing that? That's inclusion.
Yeah.
Because you can look at James Webb Space Telescope picture, on paper. Why looking at a fuzzy little ball in an eyepiece or a small telescope. And this is true for everyone, not just for people in wheelchair. And the big difference is that if you look at an object in the telescope with your own eyes, you are actually having a physical interaction with that object, because the photons that your retina left that object, left the atmosphere of the star, and so on. They did not start from a PC screen. So it's an emotional thing, right? So why excluding people in wheelchair from that? And that's why it's important.
Yeah, I think so. And you mentioned also the idea of simple materials, and I think we have some really good examples of that here as well. Andra, this is from Romania, I believe, and this is an example of how easy it is to include other people with materials. You don't need a book or electronics or anything.
Yeah, sure. This is an adaptation of a project which is also on our website, on the Subwork Group website. We have used styrofoam balls, and then we actually had fun with them. We painted, we added some wool. We were just very creative on this, trying to give them structure and different textures, because we use them both with typical children and blind kids. They enjoy them more because they feel the different structures on each planet. And they can start a conversation from there, and they have questions. But mainly this tool is used to be able to imagine the distances between the planets in our solar system, which is inaccessible for us also, and for everybody. Nobody can imagine these kinds of distances, whether you see or not.
And the distances there are proportional, which shows that we're very close to the Earth is very close to Venus, a little farther from Mars, but then very far to go to Saturn, and Jupiter, and then much farther to go out to Saturn from there as well. Yeah.
I think we go about 4 meters with this string. And we have another one. It depends on how much distance you want to equivalent with one astronomical unity. Sorry. And you can go with the string as long as you want to go. We have another one which unfolds for 9 meters for the open spaces, so that it would be more dramatic and kids can imagine the huge distances in our solar system.
And this is done for those of us who are sighted as well, in open fields in various ways where the huge distances are shown in models, sometimes permanent models like that as well. Yeah. So taking it another step further here, clearly do-it-yourself models here. So what do we have here?
Here we have some constellations on a hemisphere, which are used for group presentations with blind public. We go from constellation to constellation. These are an adaptation from planetarium presentation from Valencia. And we like to adapt even more and to go into the stories and legends behind the constellations, and talk a bit about some stars and clusters. And we can talk a lot with these resources. And the advantage is that we can have bigger groups to address using them.
Yeah, and you mentioned the planetarium program, something we don't have a picture of here right now, but this is an actual planetarium program for the visually impaired, low vision people, where they hold the dome of the sky in their lap. But what's interesting is, again, while the tactile can be very beneficial also for people who are sighted to be able to see, but also feel these things. The planetarium program can be done in a regular planetarium where the people who aren't able to see can feel it. So it's the same planetarium show, and we're all doing it together.
Yeah.
Yeah, which I think is very important, because rather than having only special schools or special events for people who are otherwise excluded. And here's another example of something that you created, and this is beautiful, and I think it looks great, but it's tactile and also something that shows, I have a globe, but it doesn't have the relief like that. So being able to see the mountains and the relative sizes and so on is a big advantage too.
Yeah, this is a 3D printed resource, thanks to the Romanian Astronomical Institute. They made it from scratch, including the modeling behind it. And this is a resource that is very much appreciated by everybody.
By everybody,
Yeah, yeah.
And
Usually in astronomy, we kind of forgot about our own planet.
oops.
People usually talk about Mars or other planets, but the Earth is a bit neglected. So we want to show it wherever we go.
Well, it's not something that everybody actually understands if you haven't seen a globe or you haven't traveled and things like that. So, and the relief is something important too. And I started to bring up something here, Cesare, to bring you back to the resources that the sub-working group has. This is some of the examples of the resources that are shown that are available for people to be able to create for themselves. Is that right?
Yeah, actually, there are the resources we share. There are also several useful information and experiences shared in the recordings of the Communicating Astronomy to the Public conference, which is the event IAU runs every year or two, where we all gather and share experience and so on. So that's also documented. There are useful information. And yeah, yes, this picture shows again simple resources, another version of the planet's distance rope that Andra talked about. Then there is a model that shows the different sizes of planets in scale. This one on the top left. One of the most interesting one is the one on the bottom right. That's the scale of the masses of the planets. So you can actually weigh those balls and go from the 1 gram of Mercury to the 5.7 kilos of Jupiter. One thing is to read on paper the mass of those planets in a very large number. Another thing is when you can feel the difference in our hands. And as you were saying, it's very important also for sighted people, for schools, because we study these things, but experiencing and having an understanding of these sizes and scales, that is not the numbers, but it's actually a feel of the proportion. It's something that only with these models you can actually get, because they are physical, 3D, you can touch them. And again, there are many things like the seasons. There is a model to explain why we have seasons, why on Earth it's hotter when, at least in the northern hemisphere, when the sun is far away. These are things that you read on paper, but when you have a model that shows you how the sun rays reach Earth and what's the difference in various periods of the year, then you get it. Mike?
And I had myself muted, as I often do. Thank you. Astronomy itself is not something easy for people to understand. regardless. And so explaining things can be difficult. We sometimes do a lot of hand waving when we're standing by a telescope trying to explain things to people, and it's not always entirely effective. So these things are good for everyone. We've shared here the website for the sub-working group where the resources are. There's also a section for best practices that is shared there, but there is also a way that you can get together with others and learn something more. And that would be the Facebook group, which is here.
Yes, thank you. And by the way, on the web page, on the website, there are also all the links to the Facebook group. There is a mail contact. There are forms to apply to be part of the group. There are forms to submit resources so that they can be added to the pool. So all the reference information is there. And the communication community is very important, and a very important aspect. And I think what you, Mike, are doing with Astronomy for Equity is very important. The activity we are trying to do to grow the community are very important, because if you gather information and publish it on a website, it just sits there. If you can grow a community, then those resources become used and they bring value.
Yeah, and thanks for mentioning that. I'm going to share here then what it is that we're doing now. This is going to be, we're actually going to be making a change here. So this is going to move to another platform more than likely, but this is something that we've been doing in Astronomy for Equity, which is an adjunct to what is being done by everybody in the sub-working group. You're sharing resources, you're providing a place where people can ask questions, you're sharing what you should do, but somehow it's not enough. And as you both mentioned, you don't know how to approach people who can't see things. What do you say? How do you avoid being offensive? How do you guide them? Do you take their hand? Do you wait for them to say something to you? And so this takes experience. And there are not too many people who want to get out there and try these things for themselves. So the idea of this community hub that we have started, which right now is on groups.io. When this airs, it may be in another place. So we'll put that into the comments when the podcast airs. That there are a lot of practitioners there who are sharing what they are doing and how they have created their own resources. As you said, Cesare, they're reinventing the wheel each time. And these resources are there. The experience is there. I liken this to having a workshop where you all get together and you can talk to each other and you can look at your neighbor and say, how did you do that? I don't get it. We need that social aspect, and that's what this is for, because there are amateur astronomers all around the world doing outreach. And we know that the whole idea is to be inclusive, because, as amateur astronomers, we've discovered the universe, and other people don't know about that. We're like evangelists. We're out there saying, hey, like John Dobson used to do, put a telescope out on the sidewalk and say, hey, come look at the moon, and that changes people's perspective. So the whole idea is to include people in what we're doing, and we're missing a lot of people this way by not realizing that they're not there. There are people that are missing there. So that's what that group is all about as well, to get these things out there, to get the knowledge out there. And hopefully someday we'll be able to tell people, oh, we're doing astronomy for the blind, and then they'll say, oh yeah, I've heard about that. That's really good. Yeah. And for those who are disabled in terms of being in wheelchairs, who are deaf, and other things. So there are a lot of cultural aspects as too. And I don't know if Cesare and Andra, do we work on that within the sub working group to make there is work on gender equality. The IAU is very big on that, but there are other aspects too that a lot of cultures do not necessarily include people in astronomy the same way that we do.
Yeah, right. And in our work group, we have also to deal with the bandwidth we have. So we are focusing on the physical disabilities for now. We are looking at the gender equality aspects, even though there is one difference because we focus on outreach, so on the public activities. We do not focus on the professional activity. In professional activity, the gender diversity can be probably more relevant because there can be more instances. In public outreach, it can be less of a critical aspect, even though the outreach can contribute to develop a more even distribution of STEM involvement in different genders.
Yeah, and the IAU, the International Astronomical Union, has done a lot of work in that regard. And it's very important because a lot of people, certain classes of people, whether it's racial or gender, are discouraged from doing science in a lot of ways. And astronomy, the whole theme of this podcast here, and we haven't even talked about it because it's not necessary. The whole idea here is to be able to include people, and we're showing the ways that astronomy is used to include people to make lives better and so on. And there are blind professional astronomers as well as outreach astronomers and so on. So there is no reason why the physical disabilities should hold people back.
Yeah.
So I want to thank you guys for joining us here. I'm going to bring up the Facebook group again so that people can join there, and there will be a link to the website there. I think this is good because you can ask questions and say, how do I learn this? And somebody will respond to you. So thank you, both of you, and thanks for the work that you do. It's been wonderful working with both of you guys. So I love what's being done. And thanks for joining us here to tell more people about it.
Thank you, Mike, for arranging this, for inviting us, and for putting focus on this important topic. Thanks a lot.
Thank you.